Nice to see you back, guys. Once again, I am back with a new project related Python OpenCV. And today in this project, we are going to control our cursor using our fingertip with the help of MediaPipe module. So let's see the demonstration what we are going to create in this tutorial. As you can see on your screen, it starts our webcam. And now I'm going to move my right hand in front of webcam. And whenever it found the landmark number 8 from my hand, it already start moving our cursor. Here you can notice all the landmark in my hand. And when I move my index finger, according to the index finger tip, it moved the cursor. Now our demo window used as a cursor trackpad. So let's jump into the Visual Studio Code editor and start coding. But before I start coding, we need to install some modules. We need to install some dependency. So let's jump into the Windows PowerShell. Before we start our coding, let me introduce you something. This project is part of my Mastering Python OpenCV course on Udemy, and as you can see, it is the new, fresh and bestseller course on Udemy. Till today, it comes with 11.5 hour plus content on it, and it comes with multiple real-world projects. So if you are interested to learn Python OpenCV from the very beginning, I will provide the link in my description. Just check this course on Udemy and you will understand why it has become bestseller. So let's back to the code. As you can see, I am in my Visual Studio Code editor. At first, we need to import OpenCV module. So I'm going to type import and our module name is CV2. Then I'm going to import another module, MediaPipe. But before, we need to install this MediaPipe module in our system. For that, you need to open Windows PowerShell and here you need to type pip install. Let me show you. Pip install OpenCV -Python space MediaPipe. Then you need to hit enter. After hit enter, as you can see, requirement already satisfied because I already download this module in my system. After that, I'm going to import this module in this file. So to type import MediaPipe as MP. I'm going to use the short form of this MediaPipe as MP. Then we need to import another module, and our module name is PyAuto GUI. Using this module, we can control mouse pointer on the screen. And using our previous module, MediaPipe, we can use hand landmarks detection. But before, we need to install this module in our system, PyAuto GUI. For that, we need to type this command, pip install PyAuto GUI. Then you need to hit enter. After hit enter, as you can see, it says requirement already satisfied because I also download this module in my system. Then let's back to the Visual Studio Code. And here I'm going to type import PyAuto GUI, this module. After that, also we need to import another module which is NumPy, which is inbuilt module in Python. So I'm going to type import NumPy as NP. So after import the required libraries, we need to initialize MediaPipe hand module. For that, here I'm going to type mp underscore hands. mp hands equal to, here I'm going to accessing the MediaPipe hand modules. So I'm going to type mp dot solution, mp dot solutions dot hand. After access the hand module, then we need to drawing the hand landmarks. So to drawing the hand landmarks, we need the utility. For that, I'm going to declare another variable mp underscore drawing. mp drawing equal to mp MediaPipe module dot solution dot drawing utils underscore utils. Then from the hands module, we need to set the threshold value for hand detection and tracking, hand tracking. For that, I'm going to type a variable name hands. Hands equal to mp underscore hands dot, from here I want to access the hand method, hands. Then inside the round braces, at first I'm going to set the minimum detection confidence value. It is used for detecting the hand. So we need to set the threshold value. For that I'm going to type min minimum underscore detection underscore confidence. Confidence equal to, and I'm going to set it 0.7, comma, then I'm going to set minimum tracking confidence value. For that, again I'm going to type, but first I'm going to turn on the word wrap, and here I'm going to type minimum underscore tracking underscore confidence. Minimum tracking confidence equal to 0.7, and I'm going to save this file. We already know the process how we can initialize media pipe hand in our code. Then we need to initialize the video capture and screen dimension. For that, I'm going to declare a variable, and our variable name is cap, C-A-P. Capture equal to, and I'm going to type cv2 dot video capture method, video capture, and inside the round braces, here we need to pass the source. As a source, I'm going to pass 0, because if I pass 0, it's going to start our default webcam. Next, we need to extract the screen dimension. After access the webcam, we need to get the screen resolution. For that, we are going to use PyAutoGUI method. So here I'm going to type, first to store the width value, I'm going to use screen underscore width, comma, then I'm going to declare another variable, screen underscore height, equal to, I'm going to call a method called PyAutoGUI dot size method. This method going to extract the width and height of the screen resolution. And next, we need to process each frame which we get from this webcam. For that, I'm going to use a while loop. Why? Cap, our cap variable dot isOpen method is opened. While cap dot is opened, then inside this while loop, I'm going to read the cap variable. I'm going to read the frame. So I'm going to type cap dot read method, and as you know, this method going to return total two results, a frame and the boolean value. And to store it in a variable, first I'm going to declare the boolean value name ret, comma, then I'm going to declare the variable name which is going to store the actual frame, which is frame, equal to cap dot read method. Then inside this while loop, I'm going to set a if condition, if not ret, then inside this if condition, I'm going to break the loop. I want to say if ret variable is false, then no frame is received. So it's going to exit this while loop. After that, we need to flip the frame horizontally for the mirror view. For that, I'm going to call the frame variable frame equal to, here I'm going to call a function from cv2 dot flip method, flip. Then inside the round braces, I'm going to pass the frame, and also I'm going to pass the flip code. If I pass 1, it's going to flip the frame horizontally. It's going to give you the mirror effect. After flip the frame, next we need to get the height and width of this frame. For that, I'm going to use a method. I'm going to use frame.shape method. So I'm going to type frame dot shape method. Shape. And the shape method from OpenCV return total 3 variables. First, it's going to return height. So I'm going to save the height value in each variable. Then it's going to return width. So I'm going to save the width value in W variable. And at last it return color channel. So I'm going to return the color channel in C variable. And I'm going to save this file. Next, we need to convert this BGR frame into RGB mode, because OpenCV by default read our frame in BGR color mode. But for media pipe processing, we need RGB mode. So I'm going to declare a variable RGB underscore frame. RGB underscore frame equal to CV2 dot CVT color method, CVT color. Then inside the round braces, first value I'm going to, as a source, I'm going to pass the frame value, frame. Then we need to provide the color code. So I'm going to type CV2 dot color underscore, and I'm going to convert it into BGR to RGB, this color code. Then next we need to detect the hand in this RGB frame. For that, I'm going to type from hands. In our hands variable, I'm going to run a method called process. Then inside the round braces, I'm going to pass the RGB frame. Which frame I'm going to process, which is RGB frame. So I'm going to pass the variable name. Now the question is, what does this do? Basically, it's going to return the result. Which result? It's going to return the hand landmarks. If a hand is detected in a frame, it's going to return all the hand landmarks, and each of the hand landmarks store x-axis value, horizontal position, y-axis value, vertical position, and z-axis depth. So I'm going to store it in a variable, and our variable name is result. Results equal to hands dot process the RGB frame, and I'm going to save this file. These are the hand landmarks I'm talking about in my hand. As you can see, here it shows total 20 hand landmarks. This is our thumb, tip, thumb joints. This is our index finger, and 8 represent index finger tip, 7 represent index finger joint. This is our middle finger, and 12 represent middle finger tip, and other number represent the joints. And this is how media pipe read our hands. So when I show my hand in front of camera, media pipe recognize all the landmarks. And as I told you, each of the landmark store total 3 values: horizontal position of these landmarks, vertical position, and the depth of this landmark. So this is it for this tutorial. It is the first part of this tutorial. At the next part of this tutorial, we are going to process these hand landmarks. And after process the hand landmarks, we are going to use index finger tip, I want to say the landmark number 8, as a cursor pointer. It's going to track this point to move our cursor. So stay tuned for our next tutorial. Thank you very much. Hey guys, nice to see you back. This is the second part of this project, and we are going to start this part to processing the hand landmark. So here, inside this while loop, I'm going to set a if condition. If results dot multi-hand landmark, we are going to use multi-hand underscore hand underscore landmark. Then inside the if condition, results dot multi-hand landmark store detected hands. If hands are detected, then I want to iterate through each hand. For that, I'm going to use a for loop. For hand landmark, hand underscore landmarks, for hand landmarks in results dot multi-hand landmarks. So I'm going to copy this section and I'm going to paste it here. Multi-hand landmarks. Then inside this for loop, I want to draw, I want to draw all the landmarks using MP drawing method. Let me show you. So I'm going to type MP underscore drawing. MP drawing dot draw landmarks. Draw underscore landmarks. Then inside the round braces, at first inside the round braces we need to provide the frame, in which frame I want to draw the landmarks, and our frame name is this variable frame. So I copy this one and I'm going to paste it here. Then after comma we need to provide the hand landmarks. Hand landmarks. Then we need to create the hand connection. So I'm going to type MP underscore hands dot hand connection. Hand underscore connection. This one. And I'm going to set this file. And after draw the hand landmarks on the frame, we need to display the hand landmarks in this frame. For that, here I'm going to type outside this for loop, and outside the if condition, I'm going to type cv2 dot IamShow method. IamShow. This one. Then inside the round braces, at first we need to provide a window name. And here I'm going to type dim. You can name it anything. Also we need to pass the frame name, which frame we want to display, which is frame. This one. After that, here I'm going to set the if condition to break the loop. If we press Q keyword, I want to break the loop. For that we need to use wait key method. Let me show you. If cv2 dot wait key, inside the round braces I'm going to wait for 1 millisecond and %, space 0 x ff equal to ORD method, ORD. Then inside the round braces I'm going to pass Q keyword. If we press Q keyword, then I want to break the loop. Break. After break the loop, I want to release the camera. So I'm going to type cap dot release method. Release. Also, I'm going to destroy all the windows. So I'm going to type cv2 dot destroy all windows. And I'm going to set this file. Now let's check, is it work properly or not? Is our MP drawing module work properly and detect the hand landmarks or not? We need to check it. So after set this file, I'm going to run this code in my terminal. So let's run the code in our terminal. After run the code in our terminal, we need to wait for some time to start the webcam. As you can see, it started the webcam. If I move my hand in front of this webcam, as you can see, it tracks all the hand landmarks. This is my index finger, and this is index finger tip, and this is index finger joint. This is how MediaPipe track our hand. If I close my hand, also it can track all the hand landmarks. You can see it. Now let's back to the code. So I'm going to press Q to quit the program. Next, we need to extract the index fingertip coordinate. This fingertip coordinate, which is number 8. Let me show you. As you can see in this image, this is how MediaPipe read my hand. And I want to extract this value, the number 8 value, this coordinate, index fingertip. For that, from the hand landmark, we need to extract the index fingertip. Let me show you how. So let's back to the Visual Studio Code. And at first, inside this for loop, here I'm going to type a variable name. And our variable name is index underscore finger. Index finger underscore tip. Index finger tip equal to hand landmarks. Hand landmarks inside these square braces is a list, and it stores total 21 key points. I want to say the landmarks of a detected hand. And as I told you earlier, every landmark store total 3 value: x coordinate, y coordinate, and z coordinate. Then inside the square braces, I want to access only index finger tip. For that, here I'm going to type MP underscore hands from the hands I want to extract the index fingertip. So I'm going to type mp hands dot, first I'm going to access the hand landmarks dot I want to access the index fingertip. So I'm going to type in capital index underscore finger underscore tip, and we need to remove this s, we don't need this, we need to type only hand landmark. Basically we retrieve 8 landmark and store it in this variable index fingertip. And now we need to extract the pixel coordinate from this normalized value. I want to say we need to extract the x-axis and y-axis of this finger point, index fingertip point. For that, here I'm going to declare a variable x equal to, and I'm going to convert it into an integer, so I'm going to use int function int. Then inside the round braces, here I'm going to type index fingertip. From this variable, I want to access the x-axis, and then I'm going to multiply with star sign, multiplication with w. Then I duplicate this line, and this is for y-axis, and here I'm going to pass dot y. This time I'm going to access y-axis, and also I want to multiply with height, width and height. In our first variable, I multiply with screen width, and in our second variable, we multiply with height. Index finger tip dot x and index finger tip dot y are normalized coordinate. I want to say the value between 0 and 1. And we need to convert those normalized values into pixel coordinates by multiply them by the frame width and frame height. As you can see, using frame.shape, here we extract frame height and frame width. So here we multiply x-axis value to width and y-axis value to height. It's going to return us the pixel value of the pointer. Let me clear the concept how it's work. Suppose we extract the index fingertip value. It is the normalized value. It always save value between 0 to 1, as I told you. So it said x-axis index fingertip x-axis value is 0.532. It is the normalized value. And this is the default camera frame size, which is 460 by 480. Width is 460 pixel and height is 480 pixel. And now we need to convert the x-axis value and y-axis value of index fingertip into pixel value. For that, we need to multiply with width and height of the frame, and it's going to return the pixel value of this fingertip. In our case, x value is 340 pixel and y value is 131 pixel, something this position. Now x and y represent the actual pixel location of fingertip in the camera frame. Next, we need to mapping frame coordinate to the screen coordinate. We need to scale up the camera screen size. Now the question is why we need to do this. Because the camera frame size and the screen size, the original screen size, are not same. They are different. So I'm going to scale up the camera frame size. So let me do that. So I'm going to type screen. I'm going to declare a variable screen underscore x. Screen x equal to, from the numpy, I want to use a method which is interrupt. So I'm going to type np dot interrupt, interp. Then inside the round braces, here we need to pass total 2 value. Basically this is numpy interpolation. It's map one range to another. Now how does it work? At first, here we need to pass a value. So I'm going to pass x value. Then after comma, inside the square braces, here I'm going to pass an array-like value. Then inside the square braces, we need to pass old minimum value, which is 0, and old maximum value, which is w, width of this frame shape, camera frame shape. Then inside the square braces, again we need to pass new minimum value and new maximum value, which is 0, new minimum value is 0, still 0, and new maximum value is screen width. And I'm going to duplicate this line. And we need to do the same thing for y-axis. Y, first I'm going to change the variable name. This time I'm going to replace x with y and w with height. And here I'm going to pass screen height. And I'm going to save this file. After save this file, now we successfully extract the x-axis and y-axis of our cursor coordinate. Now we need to move to mouse according to the cursor coordinate. For that, we need to use our module, our PyAutoGUI module. So from PyAutoGUI, so I'm going to type PyAutoGUI. I want to run move to method. Move to. This method helps us to move our cursor, and in this method we need to pass total two value, x coordinate and y coordinate, width and height, x coordinate of the cursor and y coordinate of the cursor. So I'm going to pass screen x value, screen x. Then I'm going to pass screen y, and I'm going to save this file. So it's going to move the cursor. So after save this file, now let's run the code in our terminal. And before I run this code in my terminal, we need to resolve the problem. Here we need to pass comma between this old and new value. So just put the comma, otherwise it's not going to work. It's my mistake, so I resolve it later. So after save this file, if I run this code in my terminal, and we need to wait for some time to start the webcam. As you can see on your screen, it start our webcam. And now I'm going to move my right hand in front of webcam. And whenever it found the landmark number 8 from my hand, it already start moving our cursor. Here you can notice all the landmark in my hand. And when I move my index finger according to the index finger tip, it moved the cursor. Now our demo window used as a cursor trackpad. According to the index finger tip value, it moved the cursor around the screen. It's only track landmark number 8. It do not track other landmarks. If I show you my pinky finger and move this finger, as you can see, it do not track it. At the same way, if I show my middle finger and if I move my middle finger, also it do not move my cursor. It's follow only the index finger tip. I hope now it's clear for you how we can control cursor using our hand with the help of MediaPipe module. So thanks for watching this video. At the next part of this tutorial, we are going to work on click and double click function. So stay tuned for the next tutorial.